Hello. I'm John Roycroft, Board Director and Chair of Civil and Structural Engineering at BDP. It is a great honour to be the 2024 winner of the Milne Medal. I want to thank IABSE and everybody here for their support. I'll start with a story. As a graduate engineer, I was sent to meetings on a major laboratory project, the National Physical Laboratory in Teddington. I was advised to sit and take notes and not to commit to anything. You can picture this meeting. 15 plus professionals are sitting around the table, all looking very important. The conversation is hotting up, focusing on a detailed piece of design. I'm a nervous and skinny lad, as you can see from the picture. At a critical moment, the senior engineer for my practice is struggling to articulate his message on deflections of the slab proposed. He's dying on his feet. I pick up a pencil and sketch in my notebook an image of what is being described. The client next to me suddenly holds it up and says, "This is what you were trying to say." This is one of the most empowering moments of my career. It gave me the confidence to sketch and work hard at my approach to communicating so that I could articulate my engineering ideas with flair. It was clear to me in that moment that being an engineer was not just about technical excellence, but having a range of skills that I would need to develop in the years ahead. This is what I'd like to talk about in this lecture. I want to talk about how the most successful projects are built on clear communication and strong relationships. And I want to show how sketching can help build these relationships. I'm going to take you through some key moments in my career. These moments are as much about people as they are about projects, because, as you'll hear, meeting one person can change the course of a career and open up decades of work. You'll see an evolution in my projects, from smaller scale in my early days to today's innovative low-carbon structures. And you'll also see an evolution in the teams I've worked with, from mainly male to diverse and international. It's all part of our collective shift to a more enlightened way of working. So, if you leave this lecture theatre feeling a little more inspired to bounce ideas around with others, or sketch out a radical new idea, or follow up on a chance encounter, then I shall be a happy man. So why is this lecture entitled "Send Me a Sketch"? Well, 10 years ago this month, I met Ian Ritchie with my mentor and friend Milne Medal for lunch, just around the corner from here in Clerkenwell. Michelle was my boss at BDP and is now a Fellow of the Royal Academy of Engineering. And as I'm sure you know, Ian is a RIBA award-winning architect and also a Fellow of the Royal Academy of Engineering, who has built his practice on innovative and sustainable design. He is also a very broad thinker, incorporating poetry, neuroscience and physics into his creative process. I had really looked forward to meeting this man, given his reputation and history of working with some of the industry's best engineers, such as the late Peter Rice. I had assumed that Ian would only be interested in my credentials as an engineer. But in fact, he surprised me by explaining that he was just as interested in an engineer's understanding of philosophy and the arts. He also asked me if I knew the collective noun for a group of owls. I surprised him by answering correctly, a parliament. To which Ian replied, "There is some hope." During lunch, I talked about my passion for sketching and how it formed the backbone of my engineering approach. Ian showed mild interest, and I quickly confirmed that I would send him a sketch to review. Ian then raised an eyebrow and said, "Why don't you send me a sketch a week for a year, and we will talk then?" I accepted the challenge and did as Ian asked, sending a mix of engineering sketches from my career. The first 20 sketches, I didn't get much beyond a polite thank you. But then the mood changed. Ian started asking me questions about the detail in my sketches. Slowly, we started a dialogue. A year later, I completed my Sketch a Week initiative, and I sent Ian a printed copy of "Send Me a Sketch," a collation of the sketches I had sent each week. I was invited to meet Ian at his London studio, It looked like all my hard work was finally paying off. Ian had hinted that he had a project for me to look at. I was excited and looking forward to working with one of the industry's finest architects. We sat together and Ian said, "Well, I'm glad you've come. Now let's talk about the project I've got in mind. It is a gate." To which I replied, "A gate?" I was a little surprised, having thought that Ian would have a building for me to design. Ian asked if I was okay with designing a gate, to which I said, "Of course, let's take a look." Ian produced a sketch of a beautiful gate that was based on elements of a heraldic coat of arms that represented the client who had commissioned the gate. Clearly, this was no ordinary gate project. Ian asked a series of questions in rapid succession. What is the size of the top rail of the gate? What size should the T-sections be that form the arches within the gate lattice? What do you think the size of the gate post needs to be? How deep do you think it will need to go into the ground? How will we connect the parabolic lattice members within the gate? How much do you think it will cost? The questions came thick and fast. I answered in them as clearly and precisely as I could, and we worked up some sketch details together. We spent perhaps half an hour sketching together and getting to know each other. At the end of the session, I said that I would go away and produce a sketch that would confirm everything we had discussed. There were a few basic size and deflection checks I wanted to do before committing to fabrication drawings and allowing a prototype gate to be made. I couldn't help but to smile at the end of the meeting. It was one of those meetings that wasn't quite what I had expected. Ian could see the quizzical look on my face, and he asked if everything was okay. I told Ian that it had been really interesting, but I did think that we were perhaps going to be looking at a slightly bigger project. Ian smiled and said, "We will do some bigger projects," although in the last half an hour, he had learned everything he needed to learn from me in a very short space of time. Ian explained that in just 30 minutes, asking questions about the gate, he was able to establish whether he would want to collaborate and if I was an engineer who could provide insightful and useful advice. He was clear that as an engineer, he needed me to be able to answer questions on the spot. Ian concluded that he thought I was someone he wanted to collaborate with, and he also said that the client owned a very large estate and that this prototype was one of several hundred gates they wanted to commission. This was the start of a long-standing collaboration and friendship. It was the start of a journey with Ian that I could never have predicted. I left the meeting exhausted, but having learnt much from an industry master. And this is the finished gate design. Before I talk about my first building project with Ian, I'd like to talk about how I managed to get to this point in my career in the first place. Thankfully, I've been lucky enough to have been surrounded and supported by talented people who have always provided inspiration. As a young person, I never tired of hearing tales about my late grandfather. He repaired Spitfire engines during the Second World War. He then spent 10 years in Kenya building some of the country's first roads. I never met Roland John Kent, although for me, he encompassed all the qualities of our great engineering heritage. I arrived at Bath University in 1992 to study architecture. One visiting lecturer who always captured my attention was Ted Happold. His lectures inspired me, and there was always a Brunellian romanticism when he rolled out his stories. It was at this point that I realised that engineering was the path I wished to tread. I switched to the civil and structural degree course. In my final year, I justified my move to engineering by winning the final year bridge competition, open to architects and engineers. In the same year, Mark Whitby gave a lecture, and his unbridled energy and enthusiasm for engineering engaged me. I left the lecture and composed a handwritten letter outlining the synergy I felt we shared with his approach to engineering design. A month and an interview later, I accepted an offer of employment at Whitby Bird's Bath office. It was here that I had a fantastic apprenticeship and education where I learnt an enormous amount. Technically, the role at Whitby Bird was invaluable. There, I also took on the role as chairman of the Tuesday Group. I arranged speakers and venues for the Southwest branch of the Institution of Structural Engineers. This was a great introduction to dealing with people, networking, managing a budget, and efficient planning. Above all, I realised how chance encounters could send me down exciting and unexpected paths. All this networking eventually led me to Ian Ritchie. Just a few months after the gate project, my collaboration with Ian took me to the Veterinary College at Newton Wood Barnes in Hampshire. This was an extremely interesting project and real milestone for me. The brief was to deliver new rural accommodation for the college, including the renovation of existing barns. It was for the same gates client who wanted us to explore the potential of establishing a sensitive solution to the reuse of agricultural buildings and a process with low environmental impact. The client was particularly keen to work with me as I had some personal experience of this type of structure. I had converted my own brick barn, actually a cowshed, into a home. I designed and built the house myself. As you can see, I needed the exercise. It's where I live to this day with my family. My approach on my cowshed project was to work with local materials, ideally found on site. I also wanted to save and celebrate the existing barn fabric. Starting with a sketch, I integrated the steel portal frame into the rustic structure. The exposed frame was a constant reminder to my family that I am an engineer and proud of it. The local building control was so impressed with the solution, it was sent to a high-profile practice for checking. This I took as a compliment. The Newton Wood Barns project involved a group of 2 new builds and 1 renovation, with the aim to develop a sustainable model applicable and adaptable to anywhere in the UK. As part of this project, I visited the client's own flint quarries, and we explored ways to use the materials that were at hand so that we could produce a sustainable design. We worked around slow worms and at times slow builders, but the end result sits beautifully within the landscape. The client was a visionary who wanted to support local skills and people. Together we challenged convention by reusing materials. We also collaborated with people from outside our industry. The project manager was actually the estate's farm manager rather than an architect or engineer. He asked difficult questions such as, why does it have to be so flipping expensive? Which forced us to think and design differently. Perhaps as an industry, we should be more willing to collaborate with people outside the built environment professions. Now I'd like to take you from the countryside to the heart of the city. Again, it's an Ian Ritchie project, this time an existing building in Covent Garden, so in a prominent location called Sussex House. Ian asked me to provide facade engineering advice. He had a vision for translucent cast glass external walls, separated by full-height windows with views across the intersection towards Leicester Square. I had to look very carefully at how to connect the cast glass to the structural frame to accommodate and allow for movements of the part-retained beam and part floor structure and the new reinforced concrete frame. I worked hard with Ian to develop practical and buildable connections that accommodated the movements expected and reassured the main contractor that the innovative solution was achievable. This was perhaps our most challenging collaboration together, as these were not industry standard components, materials and details. We had to work closely with the contractor to ensure they understood tolerances and how to safely install the facade system. The facade and building have been transformational and a jewel in the crown for the Mercer's estate. The collaboration with Ian Ritchie has been truly enjoyable. Ian has been a mentor, someone who has nurtured and invested in me as an engineer. He is an architect who truly understands structural design and systems. Perhaps the most refreshing aspect of working with Ian is that he does not conform. He is a creative disruptor who always looks for the best solution for his client. Ian is a true innovator, and this has taught me to think differently on how to solve any problem for a client by never refusing a challenge, by making things happen when others perhaps couldn't. This is why I believe the very best solutions come from architects and engineers who can really challenge each other and, importantly, respect each other. Early in my career, I discovered that spending time on site studying the art of construction is really important. In 2000, I spent a year on site at the IABSE Business School in Oxford, an important part of my career where I forged strong relationships with the men and women who construct buildings. Here, I quickly learned and became sympathetic to the realities of being on site and the practicalities of construction. A steel fixer asked me one morning, who was the effing person whose detailed H32 bar is 8 metres long? I said, someone back at the office. The steel fixer proceeded to tell me what he would do with the bar if he met this person in the back office. I soon realised that drawing and specifying is one thing, but you need to understand the reality. That's why I always implore every graduate to spend time on site. My time at Michael Haddy Associates during the noughties was another major step. Mike is a talented engineer, and sketching underpinned our approach. I honed my drawing techniques under Mike's guidance. He gave me high-profile projects and the confidence to take them on. When visiting a project in Cambridge, the contractor asked if I could amend my design to help buildability. I issued a sketch that night, feeling all was right with the world. 2 days later, the same contractor asked the client for more money to cover the change. Lesson learned. Around the same time, I mentored an undergraduate who really loved to sketch and had real flair. Victoria Martin, who is in the audience and now works with me as a director and sketches even better than me. In 2008, I joined as an associate the multidisciplinary practice BDP. I've learnt much from my many mentors in my career, but Milne Medal was undoubtedly one of my strongest supporters, guiding and mentoring me over many years. She is a brilliant leader and believed in me, giving me opportunities and self-belief. At BDP, I have worked on some fantastic projects, working with talented architects both within and outside BDP. My approach has always been to ensure that we are engineers of choice within the industry. This has meant that we have worked with BDP's talented architects and others, such as Hopkins, Herzog & de Meuron, TP Bennett, Gensler, Field & Clegg Bradley Studios, and Ritchie Studio. For my next project, we're heading back to London, to number 60 Victoria Embankment, 60 VE, on the north bank of the River Thames. This is where my career went up a gear, a high-profile client, a high-profile building, a big budget, no little risk, and huge pressure to match. There is also an encounter with a 6'5" executive. More of this later. I received a call from a project manager from Second London Wall, who asked if I would be able to provide record drawings of a building in central London. The project manager explained that the building in question had been designed by BDP in the 1980s. JP Morgan had now identified the need to reposition the building, unchanged since being built, as the new headquarters for its asset management team. I committed to have a look in the archives and see what I could uncover. Having found the information in the archives, it was clear that this was a major building of 400,000 square feet that had 3 levels of basement adjacent to the Thames. I agreed to meet the project manager at 60 VE to run through some of the content that I had found. The meeting went well, and I asked a simple question. Was there any way I could be involved if they were looking to repurpose the building? The project manager confirmed that it was a very high-profile client, and they typically only worked with a select few engineers on their preferred supplier list. I said, I have a team of industry-leading engineers who would exceed their clients' expectations. This could have been a risky thing to say, but over the following days, I proved our skills by revisiting structural calculations with a forensic eye and working out where we could cut costs and add value. A short time after we met the clients and were appointed as structural engineers for the £60 million transformation of the building. This was the first time that I've worked with an investment bank client, and it was an eye-opener in terms of the level of stakeholder engagement. You might see 20 people attending a project meeting with specialists in resilience and security firing questions at you. Some of the issues that were important to a bank operating on a global scale were fascinating and challenging. For example, can you guess the financial impact of shutting down an investment bank for just 1 hour? The numbers are staggering. The project was particularly interesting as there were 2 architects appointed, Gensler and TP Bennett. As the engineers, we were providing continuity between the 2 parties. I remember receiving a call on a Saturday from the client representative in New York. He wanted to know whether we could remove a ground floor structural column near the entrance of the building that supported 6 floors above. Being very familiar with the layout of the building, I was able to reply that it should be possible, but I was careful to add a series of caveats. The American gentleman at the other end of the phone was very direct and said, I don't want caveats. I want to know whether we can take the column out or not. If you can confirm now we can take the column out, then the project will move forward. But if you cannot, it will stop. So I confirmed it was possible, but the structure above would need to be jacked and significant new structural strengthening works required. I said I'll work up a sketch and show you how, but I need to drop my son off for rugby practice first. I'm not sure how the rugby practice line went down, but the client thanked me and said he would look forward to receiving the sketch that confirmed the column was coming out. Much like the gate conversation with Ian, it is important that clients feel they can trust an engineer. Clients want to see strength of conviction and that they are in safe hands. But as a profession, we are naturally cautious. This is for good reason, as we carry huge responsibility. The project was an extraordinary journey. We developed a complex and detailed information set that demonstrated stage by stage how we could safely remove the column and keep some of the trading floors above operational. The removal of the column cost the client a lot of money, although the vision of the architect was outstanding. The space that it created to insert a beautifully designed glass entrance box was well worth the effort when you look at the scheme compared to the original building entrance. As part of the process, we were asked to present to around 200 stakeholders from JP Morgan Chase. The architects, the environmental engineer, and I were asked to present a summary of our proposals to this very switched-on stakeholder group. Over the last 30 years, I've worked with many wonderful structural engineers, but in my experience, the area that many of my contemporaries fail to capitalise on their ingenuity and brilliance is being able to articulate an engineering story. This was a wonderful opportunity to share the complexity and Brunellian romance of what we were trying to do. I was able to demonstrate that the building they already had was itself an engineering feat, with a 3-storey basement constructed top-down, like many buildings that were being constructed today in London and promoted as innovative construction techniques. I explained at high level the complexity of our proposal and introduced a scattering of drama in my description of how we would jack the building. At the end of the presentations, the client sponsor gave a summary. He said that out of all the presentations, the structural engineering presentation I had given had surprised him, as it had actually been the most interesting. The comment was much to the irritation of the architects. Meanwhile, John Robinson, the client's head of design and construction and the project lead, confirmed that everybody was excited about the project, and he also committed to be on site when we removed the column. Let's be honest, jacking is slow, meticulously planned, and really quite boring. It's not really a big crowd pleaser if all goes to plan. But I like the fact that the client was keen to come. A client who is interested is your greatest supporter, I thought. 2 weeks before the day of the jacking, I was called to site to meet an individual. I shall call this man, because no one wants a lawsuit, Mr. JB. This was a meeting that had come late into the diary. It was with JP Morgan's global head of construction. A risk assessment of the project in New York had triggered a response that, due to perceived complexity, would need sign-off from Mr. JB, who had the power to call off the jacking. There was a general state of panic, both with the main contractor and client side, as Mr. JB had a reputation and connections with the top table at the investment bank. I was told again with minutes to go before meeting Mr. JB that if this meeting didn't go well, the project would stop. Mr. JB's word is final, is what I was told. When I walked into the room, I met an intimidating man. He must have been 6'5" tall. But once we looked at the drawings together, it became clear very quickly that he was an incredibly knowledgeable and interesting man with a lifetime of knowledge and experience of the construction industry. We talked through in detail the jacking operation, and he fired detailed questions at me. Have you done this before? How will you remove the column? How will you measure deflections? Have you personally double-checked everything? I enjoyed the attention. My view is that we should always welcome peer review, as it is always better for a project when we scrutinise together. I knew the scheme inside out and was able to enjoy the design review with the towering Mr. JB. It was just part of the process. Mr. JB said he was completely satisfied that I had everything covered. He shook my hand and left to catch a plane back to New York to report back to the mothership. Let me take you to the day of the jacking operation. As you can imagine, it was tense. When we'd completed the load transfer over the morning and were finally thermally lancing the column, there was a palpable relief that things had gone well. The client, John Robinson, shook my hand and smiled for the first time that day. The relief on his face was clear to see. For me, the key message in this project is that you must take the client on the journey with you. If we share our engineering ideas and story creatively with clients, and if we treat them with respect and take the time to explain to them how we plan to create their buildings, they will respond positively and be our greatest supporters. We have completed many other projects with this client, and to this day, when something complex needs doing, the phone rings and I'm called in to help. What we achieved on this project was exceptional. Nearly every relationship with every consultant and contractor has endured. Kevin Mulligan, the contractor leader, and the client John Robinson, who are both in the audience tonight, have both brought me new project opportunities, and we have collaborated successfully over the last decade on the back of what we achieved together. When we discuss business development within my company and which events to go to, I remind people that the best business development strategy is always underpinned by doing an amazing job. The JP Morgan project gave me confidence that I could handle multi-million-pound jobs. I could also see how, as an engineer, I had a real share of voice. I could actively shape a project and not just deliver the architect's vision. Great Ormond Street Hospital, or GOSH, was a design competition launched 8 years ago. It attracted global architect names and interest. It called on every member of the design team to contribute something exceptional. As part of the design competition, I produced engineering sketches to help shape the emerging design and demonstrate to GOSH in user group meetings that we were an active part of the team. We were there to help shape and deliver their hospital and vision. And our very own Benedict Zucchi, lead architect on the project, brought his concept to life in quite magical ways. Against stiff competition, including Danny Boyle as part of one team, we won the project. After a slightly delayed start, we are busy working on the hospital and have commenced construction. The next project was high pressure as well as high altitude throughout. Could I handle the pace of working with an international Swiss architecture practice, respond speedily to an emerging design, bring structural elegance whilst embedding pragmatic buildability, drastically reduce costs? You won't be surprised to hear that sketching came to my rescue for all of the above. The project was with Herzog and de Meuron Architects, HDM. I led the structural engineering response on the £500 million Discovery Centre, a state-of-the-art global R&D facility in Cambridge. The plan was to accommodate more than 2,000 scientists. Working with HDM was challenging, but ultimately very rewarding. In the same way that Ian Ritchie challenges structural design, HDM are relentless in the pursuit of the best design solution for their client. The journey is not for the faint-hearted. My key challenge was to seamlessly integrate a rational structural approach. HDM has a head office in Basel, Switzerland, and at the start of the project, I was required to visit Basel every other week. Every time I went to Basel, I needed to present new structural responses to inform the emerging design. The HDM studio is a collective of highly driven architects who work in a very focused and creative way to generate lots of ideas. This put huge pressure on me and my talented team to provide focused support at pace in order to keep work streams aligned. The design was fluid. HDM were relentless in the pursuit of excellence. I had to respond in a seamless way, so I came up with an idea that I've now embedded into all projects at BDP. We developed a concept called the structural sketchbook, my idea being that we capture structural thinking along the way. Typically, engineers produce drawings from BIM models at key gateways and stages that are agreed at the outset of a project. This approach can be limiting, as cost consultants and other members of the design team perhaps do not see information until quite a late stage. This can cause costly reworking of the scheme if things aren't affordable or don't work. My idea of the structural sketchbook was to integrate early thinking and preliminary calculations and eventually even analysis models into sketches. Typically, the kind of things we would have left on the desk and not shared. Our approach meant that we could demonstrate in real time evidence of our structural thinking. It was a very effective way of capturing structural narrative and encouraging useful and insightful interdisciplinary discussion at design team meetings. On a project of this scale, which went through many iterations of design and cost review, it was imperative that we could play back earlier thinking. demonstrate that ideas had been explored and discounted for various reasons. When presenting to the design team during my Basel visits, the stakeholder engagement lessons I learnt on projects such as the JP Morgan project proved vital. With the structural sketchbooks to hand and having a structural narrative to underpin my approach, I was able to think on my feet and adapt and design in real time. The concept stage was a real challenge, but ultimately extremely rewarding. In this type of environment, there is nowhere to hide. The architects want answers there and then, just as Ian Ritchie did with the gate design. My leading role was only possible with a hugely talented team back in the office who tested ideas and made what I said could be done possible. They never let me down. Despite the prominence of pen and paper in my career, I don't always rely on sketching. I'm also keen, wait for it, spaghetti. My approach to building confidence and sharing ideas is about interaction and using what is available. And a great way to describe structure is through physical models. This is why I use plasticine and straws or spaghetti when young people visit the studio from school. This photo shows a model that we had in the Basel studio where I used pencils to demonstrate where long span beams might be placed for a particular solution that we were exploring at the time. When I wasn't in Basel, we will still need to have conversations with the wider project team around ideas. This sketch is a follow-up to a telephone conversation where I'd been talking to a Brazilian architect in the Basel studio about cruciform beams around column heads. It's a good example of using sketching in a very quick and conversational way. Sketching is about communicating ideas, not producing works of art. In my sketching classes, I often show this image of Mark Brunel's notebook to prove this important point. The Discovery Centre, from a structural point of view, was a complex and unique challenge. Essentially, design involves a series of cantilever slabs around the building of varying spans. A key consideration was deflection and creep of the concrete cantilevers, something that I had to think about very carefully and led to a collaboration with experts at Leeds University. Early in the concept design, we modelled how the facade could be supported. It was important that the team understood the implications of early decisions. At this early stage, it was very clear to me that if the long-span steel roof with large cantilevers was procured separately from the facade, then the split in responsibilities between the two specialist suppliers would be extremely difficult to accommodate and reconcile during construction. I worked tirelessly to demonstrate that the roof and facade should be procured through a single entity rather than through two separate suppliers. The work in presenting the case for a single package procurement route was very involved and time-consuming, but was rewarded with the team agreeing to tender facade and roof as one single package. This was a very important moment and highlights again that it's the role of the engineer to not just design exceptional structures, but to consider how to safely build them and de-risk procurement issues that could result in on-site problems. A key part of the brief was around vibration. The labs must respond predictably. The structural frame would need a rational response embedded within the complex form that was developing. Using sketches, I was able to guide the architect and make sure they understood these key and fundamental issues, and that they were integrated into the emerging design. Once again, the structural sketchbooks proved a vital communication tool, but they only work if you take time to explain the content. The explanation and the drawing go hand in hand. The roof design was something that I considered from an early stage. This was an area where I felt that the architect, and I appreciate there are several architects in the room, had the wrong solution. The sawtooth profile was originally shown as reinforced concrete. This was, in my view, at odds with long-span lightweight principles. One of my first steps was to convince the architects that a lightweight steelwork frame was the right way forward. This sketch tackled this immediately. From my sketch, we developed a table with deflections and other data shown here. This helped to shape a constructive narrative with the design team. As part of the solution, I also took it a step further. I made sure the roof could be fabricated in 12-metre long sections that could be transported to site with glazing and finishes in place. This approach was delivered on site where we stitched together the completed roof sections. To achieve this, it was important to design the roof from the outset with this in mind, as the connections at the stitch and splices informed the size of the members. Inevitably, on a project at this scale, there were value engineering challenges to face. One day we were asked to attend the project manager's office at short notice. The client sponsor outlined a serious cost issue that could delay or even stop the project in its tracks. We, the design team, were tasked with going away and finding significant savings, with the risk of the project not proceeding if we didn't. The project sponsor articulately described the work being done to find cures for varying diseases and the important research that this building would promote to help deliver innovation to tackle these issues. It was an inspirational pitch by the client and one that had to be matched in a response from the consultant team. Travelling back after the meeting on the train, I produced this sketch. It sets out my ideas on how to reorder structure and reduce depth of the slabs and their cantilevers. The sketch that I produced in response to the value engineering challenge showed and explained the logic behind ideas to look at grid rationalisation and reduction of depth of slabs. Ultimately, the ideas led to around £10 million worth of savings. The sketch was only the start. The key was working through the ideas with HDM to demonstrate that it could work within their architectural vision. The client was very complimentary when I sent him the sketch on the same day he had asked for the team to find savings. He recognised our commitment and ability to shape the project, and it culminated in him taking my team out for lunch. A lovely thing to do that embedded a sense of pride in my team. This demonstrates something that has underpinned my entire career. It is essential that the engineer leads from the front and rises to every challenge that comes along. It is not just the technical aspects that need to be brilliant. It is also important that you support a client, take time to understand their vision, and become their strongest champion. Sometimes when you challenge convention and propose an innovative idea, the concept is too radical for a client. This, of course, is all part of a long and varied career. It also stops you from getting too big for your boots. However, a loss isn't necessarily a loss forever, and it's often possible to make your contribution further down the line. The next laboratory project is a good example. A bidding opportunity came out of the University of Cambridge for the new Cavendish 3 laboratory, now known as the Ray Dolby Centre. This was a fantastic opportunity, especially on the back of the work we were already doing. I worked hard to put together a comprehensive proposal to be part of the concept design team being selected. We were shortlisted for interview and had a very positive interview where I presented an alternative structural concept on how we might deliver the vibration performance aspects of the proposed physics laboratory. My concept idea and sketch was something that I developed in collaboration with the University of Southampton, ISVR, who are industry experts in vibration. It was a low embodied carbon solution, and I believe my approach challenged convention. I was making my first proper stand to reduce carbon in labs, a real awakening for me. But some great work had already been done by the briefing team, and I recognised that my solution called for a quantum leap of faith. Unfortunately, we were not successful. Everybody in this room learns to handle rejection. You ask for feedback, you dust yourself off. The winning engineer was and is brilliant in his own right. So whilst disappointed, I was happy for the client and the project. But wait for it. We were approached again at procurement of contractor team stage and joined the Bouygues UK team, who were appointed to deliver the detailed design and build of this £250 million physics laboratory. I led the contractor delivery team for BDP that included structural, civil, vibration, MEP, and acoustics. This was an incredibly challenging role, integrating engineering across multiple engineering disciplines. I even led and coordinated reflective ceiling plans. That was a career first for me. We also worked very successfully with the engineer who'd won the early stage commission. The solution they proposed has achieved the stringent vibration criteria set in the brief, so it's been a great success. The project was challenging in terms of scale delivery and programme. I worked very closely with the contractor, as this had multiple phases being constructed in parallel. We worked tirelessly to reduce material on the project, and we refined reinforcement in slabs and simplified construction details. I identified that the design in some areas had opportunities for material savings, so I rolled my sleeves up and sketched alternative options for consideration in a few key areas. On a large project such as this, it's imperative to be an active problem solver and persistent with it. By being able to respond immediately, I could quickly intervene and show a material saving. Being able to sketch quickly and often under pressure can unlock these benefits by instigating dialogue. The project has recently completed and is now a world-leading centre for physics research. Everybody in this room is individually responsible to cut carbon. As structural engineers, we need to take action to significantly raise our game in reducing embodied carbon in the construction materials we use. So it makes sense to finish my lecture today with the following two projects. The first will be the largest net zero carbon laboratory in the UK. The client is the John Innes Centre, JIC, at Norwich Research Park. The next generation infrastructure project rationalises the site. It brings scientists from lots of different backgrounds together into a multidisciplinary environment, a space for true collaboration. At interview, we proposed a new approach featuring low embodied carbon materials. We made it clear we were rejecting the traditional carbon-hungry laboratory solutions of the past. The client bought into our approach, and BDP won the commission for the £400 million new centre. We developed timber options, but despite detailed assessments of predicted vibration performance of the structure, we were struggling to achieve the vibration criteria that the client required in the brief at an affordable cost. This was one of those key moments where I think as an engineer, you must believe and follow your convictions and do what is right. I remember speaking to Keith Papper, the lead architect at BDP, and relaying that we really had to make this happen. How can we address climate change if we can't solve this issue? It was during the conversation that I had a moment of clarity. Often as engineers, we try to calculate our way out of a problem. But as we talked about mass tune dampers and other ideas, it occurred to me that we need to look at things from a different angle. I explained to Keith that the vibration criteria curves are an industry standard that was set many years ago and related to a period when scientific equipment was less advanced. It occurred to me that largely those vibration thresholds have not significantly changed since the early 1980s, despite scientific equipment changing radically. I suggested we revisit the vibration criteria we were designing too. Perhaps by working with the client, we could demonstrate that their science could be just as effective at a more appropriate vibration performance. We might save the timber concept. This approach, working with Tom Carr and my team and our friends at ISVR, meant we were able to develop a timber concrete hybrid design, which ultimately unlocked the potential for a low embodied carbon solution. The impact of reducing embodied carbon has been significant, as this graph shows. We are now tendering to contractor teams. We have a progressive solution of a timber and concrete hybrid that will deliver a sustainable and low embodied carbon lab. It is this approach of challenging the status quo that is now so important for engineers of today and tomorrow. My final project today is the Warwick University STEM building, which is an ongoing project. I remember walking past a major building in London the day before the interview, and there was a line of dumper trucks, maybe 20, queuing up to get onto a major site to take away spoil from the basement that they were excavating. I had just 2 slides to present at the Warwick interview, and for one of the slides I showed this photo of dumper trucks queuing up. I made a clear commitment that if appointed, that we would not be introducing a basement. If you consider sustainability and healthy campus life as central to the brief, we really shouldn't be exporting material off-site and causing construction traffic chaos. This approach, I think, reflects a journey I have been on and how experience brings confidence to stand up for making key decisions as an engineer. As an engineer, you cannot be passive. We won the project and we just completed concept design stage. To sum up, I believe that amid all the technological buzz, it's really our relationships that drive the best project outcomes. To deliver buildings and infrastructure, we first need to build strong relationships. And I'm as proud of the friendships I've cultivated as I am with the structures I've designed. In fact, working with people has been the most enjoyable aspect of my 30-plus year career to date. From my undergraduate days at the University of Bath, where talented individuals took me under their wing, to BDP today, where I lead 80 engineers, I could not have made the journey without people. Having fun as part of the process is also something we should embrace as an industry. And of course, sketching is at the core of my approach to engineering. It's such a brilliant tool to forge friendships, collaborate, and solve problems. I now run sketching classes for engineers in the BDP studios, and I hope that young engineers will continue to use sketching as a primary tool for communication. Sketching is not a talent, it is a skill. and I'm thankful to Ian Ritchie for challenging me to produce a sketch a week for a year. Thank you.